All right, welcome back. This is a little addition to our previous video on subtracting polynomials. In that video, we subtracted this polynomial from that one, and we got the solution over here. Before we did that, we talked about subtracting just regular numbers in base 10, where we have ones, tens, and hundreds, and we're subtracting these two. And we did it in place value columns like this. 821 minus 230. We subtracted, we got 1 minus 0 is 1. 2 minus 3 was going to be negative 1, and so we would take away one of the hundreds and put it on the tens. So we have 12 tens minus 3 tens is 9 tens. And then we had 7 hundreds left minus 2 hundreds is 5 hundreds. That gave us 591. That's the traditional approach. I want to show you that you can do that same process the way we did with the polynomials, and it will give you the right answer, okay? So instead of borrowing, let's look at it like we did with polynomials. We have 8 hundreds plus 2 tens plus 1 whole, and we're subtracting 2 hundreds plus 3 tens plus 0 wholes. All I've done is broken this number 821 into its place values. It's a sum of hundreds, tens, and ones. And I've put 230 in that same format. A number of hundreds, a number of tens, and a number of ones. So when we subtract, we get 1 minus 0 is 1 whole. We get 2 minus 3 is negative 1, 10. And we get 8 minus 2 is 6 hundreds. Now, what we have here is a number, 6 hundreds minus a 10 plus a 1. Well, 6 hundreds minus a 10 is 590. 590 plus a 1 is 591. This gives us that same number as we got before. So I wanted to show you that because even though this is not the typical way we do subtraction in base 10, it does follow exactly the same way as we showed with the polynomials. And this would be an acceptable answer to the problem, 821 minus 230. That's a true statement, that this is the solution to that subtraction problem. Of course, we can write it more simply, right? Which is why you're taught to do it this other traditional way, where you end up with that simplest form. Unfortunately, in polynomials, we can't simplify that because we don't know what x is. If x was 1, this would simplify to negative 2 plus 3 minus 16. If x were 10, this would be negative 200 plus 30 minus 16. And you would simplify those things and get a different result depending on your base. So, this is the final solution in the subtraction of these polynomials, and it doesn't matter what x is. This is the final solution here because we do know what x is. In these numbers, x is 10. We have wholes, we have tens, that's 10 to the first, and we have hundreds. 10 times 10 is 100. Hope that helps. See you next time.